Thanks everyone for coming. How was your first day at I/O? Awesome. We've got one more talk for you. I'm Bryan McQuade,
I'm Libo,
and we'll be talking about using page speed to optimize your website for mobile. So feedback link, hashtags. So we'll start with a little background on page speed itself before we dive into mobile specifics. How many people here are familiar with or have used page speed? Great, good to see. So for those of you who aren't familiar with our tool, page speed is a tool that performs analysis on a web page. So you run page speed on a web page. It analyzes the content that you serve, so your HTML, your CSS, your JavaScript, your images, etc. Analyzes that the things sent, the headers, HTTP response headers, content, and comes back and generates specific suggestions to make your page load faster without changing the way that that page appears in the user's browser. And so we're available today via browser add-ons for Firefox and Chrome, via PageSpeed Online and Google Labs, pagespeed.googlelabs.com, which we launched about a month ago. The PageSpeed Online API, which allows you to get the raw data, the raw page speed results data, and process that as you wish, which we launched actually yesterday at Boot Camp. And then via some third-party integrations with Web Page Test in the Gomez Recorder, which Amir Rosenberg, who is here today, will talk to us about in a few minutes. And then yesterday in the WordPress plugin W3 Total Cache. So W3 Total Cache now uses the PageSpeed Online API to provide page speed suggestions right in the WordPress dashboard. And so if you're not familiar with PageSpeed, this is the UI, the PageSpeed UI here. And what you get, this is one of our browser add-ons. What you get when you run the page speed on a web page is you get this sort of summary, which starts with the page speed score at the top, 91 out of 100 in this case. And what the score indicates is essentially how much room there is for optimization opportunity on your page. So a really high score indicates that there's very little that page speed has to suggest to make your page faster. In other words, you're doing a really good job and your page is really as fast as we know how to make it. Whereas a low score indicates that there's lots of optimization opportunity on your page. There's lots of room to make the page faster. So in this case, 91 out of 100 indicates that this particular page, which I believe is the page speed page itself, is doing reasonably well, a green check mark. And so underneath that, we list the specific suggestions ordered in importance for that page, starting with we see leverage browser caching, defer parsing of JavaScript. Each of these is a page speed suggestion. The first one is yellow, so it's sort of a medium priority. There's also a red category. In this case, there are no red sort of high priority suggestions. And so you may look at this and say, well, okay, PageSpeed says I should leverage browser caching or I should defer parsing of JavaScript, but what does that mean? What specifically are you telling me to do? And so you can click on any one of these headings and expand it. So in this case, we would specify a cache validator, one of the PageSpeed suggestions. And you can see the specific suggestions associated with that PageSpeed rule. So for this site, these specific resources, we believe, are missing a validator. And we sort of explain up top with a little bit of text that by adding a validator, you can reduce the overhead of content refreshes from the server. If you're still sort of wondering, well, what does that mean? Why should I implement this, or what specifically do I need to do? You can actually click on any one of these headings, and you'll be taken to our documentation on the web, which goes into specific details for each of these rules, and we'll tell you, why you should implement this and how you can do that. And so that's page speed. And now we'll look at the agenda. So we'll be covering 4 topics today, 4 sort of topic areas. First, a web performance overview. And then we'll look at key differences in performance for mobile. And then based on that information that we've covered, we'll look at new page speed rules targeted for mobile. And finally, we'll do a brief survey of tools available for mobile web performance analysis. So first, we'll do a web performance overview. And so before we dive into sort of the technical aspects of web performance, we wanted to spend a little bit of time talking about why it's important to optimize your site, why it's important to make your site fast. And so we've got sort of 3 statistics here. 2 of these we actually showed last year in our talk at I/O, and one that's sort of new and specific to mobile. So first, Google did an experiment a couple of years ago, several years ago, where they added latency, 400 milliseconds of latency to search results pages. And we observed that as a result of adding that latency, there was a 0.6%, statistically significant 0.6% decrease in search interactions as a result of that latency. And so what we saw is that by making the page slower, people used it less. And conversely, making the page faster, people would use search more. And so there was so that really drove the point home internally that it was really important that we make our product as fast as possible. And so secondly, a statistic that came out of the Velocity conference in 2009, Shopzilla did a complete site redesign where they were focused on performance, and they were able to actually make their page 5 seconds faster as a result of that redesign. And what they saw is that not only was their site faster, but they saw a 12% increase in revenue, and on top of that, a 50% decrease in hardware costs. And so in this case, they saw a faster site led to increased revenue and actually decreased costs as well. And so finally, a third statistic that we wanted to share this year that came from some internal work. When the Google Maps team added one of the best practices that we'll talk about on a future slide, targeting mobile, using an HTML5 application cache, they saw that their average page load time for the Google Maps product for mobile devices went down by 3 seconds. So implementing that one suggestion had an impact of 3 seconds on their load time, their average load time. And so we're starting to see lots more interesting statistics come in internally, and we're excited to continue to share those. But what we're seeing is that consistently, where performance optimizations make sense on desktop, they make even more sense in the mobile space. So for instance, a 3-second overview from one optimization is a really substantial improvement. So let's go ahead and look at the life of a web page load. We sort of have 3 components here. We have the server, network, and client. And of course, the first thing that happens is the client says, they want to fetch some web page. A request is sent to the server, and the server spends some amount of time processing that request and generating the response. And so typically we're looking at 100 milliseconds, maybe a couple hundred milliseconds to generate that response. And if you're familiar with Steve Souders' work, you'll know that in fact that's a minority of the overall page load time. In the life cycle of a page load, Steve talks about this in his talks and in his books. In the life cycle of a page load, that time spent generating the result on the server is actually a very small part of the overall page load time. The rest of the time is spent on the network, namely due to bandwidth and round trip. So if you've got a lot of content on your page, you may be bandwidth limited. If you've got lots of resources on your page, you're going to be issuing lots of requests, and round trip is going to be a dominator. And then once that content arrives back at the browser, we're looking at things like parse time, sub-resource fetches, layout and rendering, which is clipped, unfortunately, and JavaScript parse and execution time in the browser all contribute to the sort of time it takes to load a page. Yeah. So let's look at this sort of from a different view. We've got 3 columns here. We've got a client column, activity that's initiated by the client, server column, activity initiated by the server, and then a third column, the render state at that point in time. So essentially, what does the screen look like for the user at that point in time? And so what we can see here is that the first thing the client has to do in desktop is issue a DNS lookup, which takes a round trip. And essentially what's happening here is, the user types in foo.com, the browser says, okay, I need to find the IP address for foo.com, they send out the DNS server, the result comes back, and then they can proceed, and the browser performs a TCP connection to the IP address that came back in the DNS lookup. And so each of these steps here is a round trip to a server. And in desktop, that's typically on the order of 40 milliseconds to 100 milliseconds. In the worst cases, it can be a second, but typically between, I'd say, 40 and 100 millis. And so then we begin a third round trip to actually send the request to the server. The server begins processing that request and begins returning data. And finally, at this point, after these 3 round trips have elapsed, we start to see content render on the page. And so at this point, parse and layout starts to take place. The browser discovers sub-resources in the HTML content and starts to issue requests for those. We can see images in the results page. And then those results start to come back, more content is rendered, and eventually the page finishes loading. So that's sort of the life cycle, in the sort of client server, and then what does it actually look like for the client? And so we can see here that actually, in the sort of typical cold case, the browser has to issue a DNS lookup, TCP connection, and send the HTTP request, 3 round trips, all before any content is rendered on the screen. And so in a minute, we'll look at how that differs on mobile.
Next, we will talk about the key difference on mobile. There are 2 types of differences. One is the network. We all know on mobile, the round trip time is longer, and we have a lower bandwidth. And also, the devices is different. The mobile devices have less CPU power and less memory. And there is another unique difference. is the interaction model is quite different. The mobile phones or tablet use touch screen, and laptop or desktop use mouse or trackpad. We will talk about this in detail later.
And so first, let's look. So a minute ago, we looked at the diagram with a Chrome desktop browser, web server. So now let's look at the differences in mobile. So Libo talked about some of those differences. And so one of the biggest differences is that the device itself is not connected all the time. It's not connected to a Wi-Fi network. It's not connected to a hardwired like a desktop might be. And so when it wants to talk on the network, it has to establish a connection. And so as a result, we'll talk about in more detail what that means for mobile performance. But we see differences in bandwidth and round trip time as a result of being on talking over to a cell tower. And then because the devices are less powerful, as Libo mentioned, because they're relatively less powerful than desktops or laptops, we see increased parse time and increased JavaScript time. JavaScript parse and execution times in the mobile space. And so first, we'll talk about each of the categories that Libo mentioned on the previous slide. The first of which is round trip times. And so the most important thing here is that initial mobile channel establishment time can be substantially higher than typical round trip time that we're used to on the network. So if the device, so if you pick up your mobile device and you type in example.com, and the device has been inactive on the network for about 10 seconds, at least on 3G networks, we've seen that the time it takes to establish a channel with the mobile tower is on the order of about 2 to 3 seconds. And so before the device can even issue that DNS request to sort of say, what is the IP address for foo.com or whatever site the user is navigating to, you're looking at a 2 to 3 second delay while the device establishes a channel with the tower. Now, once that's done, what we've observed on 3G is that the sort of active channel round trip times are substantially lower. So, on the order of between as low as 40 milliseconds up to 100 milliseconds. And so while in the desktop space, when we talk about round trip times, we're used to thinking about sort of a unimodal distribution around a single average round trip time, what we see is that in the mobile space, for a single client, there's actually multiple modes on the distribution of round trips. That one mode associated with the channel establishment up around 2 to 3 seconds, and then a second mode for active channel round trip times in the 40 to 100 millisecond range. And so we'll talk in a future slide about what this means for performance and sort of how you can build your site such that it's not sluggish in the face of these highest channel establishment times. But before we do that, I'll just mention 4G may have different characteristics. Some initial studies we've done look like that the channel establishment time is substantially lower in 4G. It's too early to say for sure, but we'll be keeping an eye on that, and you should as well. As 4G rolls out, things may improve substantially. But for 3G anyway, the times are on the order of 2 to 3 seconds, which is just a huge latency hit.
The mobile network have evolved so much recently from the 1x, 2G, 3G, but compared to the wired network, it's still has very low bandwidth. A typical 3G network now has only about 800 kbits per second download bandwidth and about 400 kbits per second upload bandwidth. On the wired network, the bandwidth is much higher. We have seen studies showing 2 megabits per second for the cable network. At my home, I have the internet provider has like 25 megabits per second for download. So the comparison is obvious. 3G network has much lower bandwidth. The CPU power is also obvious. There's no doubt that the mobile devices still have a low CPU power. Here, we show a table that shows my MacBook Pro running the JavaScript benchmark SunSpider. It has 427 milliseconds. The Nexus S is the new Google phone. It has more than 5,000 milliseconds. The Samsung Captivate has older Android OS. It has more than 12,000 milliseconds. We can see clearly the desktop is still 10 times faster than mobile. And the So in this case, the JavaScript need more time to be parsed, to be executed on your mobile phone or tablet. And also it needs more time to render the layout. Because the phones has less memory, it may need more frequent garbage collection. And so it's etc. The other unique difference is the interaction model. Desktop and laptops use mouse or trackpad, it's the same as mouse. But on your mobile phones or tablet, you use the touch screen. So the mobile browser won't fire the click event until 300 to 500 milliseconds delay. At that time, the browser or device decided this is just one click, not double click, not pinch, not other interactions.
And so now, based on the differences that we've covered, let's look at that same view, that same 3-column view for mobile. And so, as we talked about, the most sort of significant change here is that initial mobile channel establishment that the device now has to perform when it wants to issue a request. And so, that's actually issued to the cell tower, which is sort of a fourth component in this graphic. And so now, so I should mention too that this is not to scale in terms of amount of time. As we talked about, we're looking at 2 to 3 second mobile channel establishment, and 40 to 100 to maybe several hundred millisecond DNS lookup. So that channel establishment actually should be substantially taller, but we're space limited, and so it's not as big as it should be. So once we establish a channel, things start to look much more like desktop. So we see that DNS lookup round trip, TCP connection, HTTP request to the server, content starts to come back, and here now we've got a mobile view, and it starts to render very similarly to the desktop at this point. The device issues its sub requests, that content starts to come back, and the page view completes rendering. And so we see here too that parse and layout step tends to take longer on the mobile device because the device is just less powerful. And so in this case, the Google search for mobile is actually substantially simpler in terms of the number of DOM nodes and the amount of JavaScript as compared to the desktop version. And so even though the device is slower, we see that it still renders very quickly. And so it's important to keep in mind that if you're taking a desktop app and you're just going to port it over to the mobile space, you should expect that same desktop app is going to be on the order of about 10 times slower when you port it over to mobile. So it's important to be thoughtful about, do I really need all this JavaScript in the mobile space? Essentially, prioritize the content that's most important in mobile, and especially because the screen real estate is less too. Certainly there's likely a lot of content that you can exclude from that initial page view in order to make that initial page view faster. Okay, so we covered the key differences for mobile, and now we'll take some time to look at page speed rules that we've derived from these key differences. So we'll look at page speed rules that we've added to page speed that you can see on Page Speed Online, in our other tools, that will suggest essentially fixes that address these differences in mobile. And so there are 5 rules that we've added, and we'll go through each of these. Use an application cache, defer parsing of JavaScript, make landing page redirects cacheable, prefer touch events, and enable keep alive. And some of these we've added already. Some of them are under active development. You can expect to see them added to page speed in the coming weeks and months. And we'll also be adding additional rules going forward that aren't listed here as we learn about new mobile best practices. So first, use an application cache. So the idea here, so this is actually the exact suggestion that the Gmail mobile team, the mobile version of Gmail implemented, and they saw about a 3-second reduction in page load times for that application. And so interestingly, that correlates with that initial channel establishment time that we talked about earlier, 2.5 to 3 seconds. It's not clear that they're the same for that for a reason, but it's interesting to note that essentially what the benefit of using the application cache is that you're able to avoid that initial very expensive round trip to the server because the content is cached locally on the device. And so that as soon as a user types in, maps.google.com or whatever site they may type in, that content starts to load before the request has to even be sent on the network. So the frame of the page, for instance, the content that's static can display immediately and really let the user know that this page is starting to load quickly. It's there, and the idea is that the user doesn't get sort of frustrated or discouraged and leave. They say, okay, great, some content is loading. And then as the network becomes available, as the mobile channel is established, the device is able to start sending requests to fill in sort of the dynamic parts of the page at a later time. And so using a manifest is an HTML5 feature. HTML5 application cache is a pretty simple thing to do. You just add a manifest attribute to your HTML tag in your HTML document that refers to a file, in this case, my manifest on the web server. And that page, which we'll actually see an example of this content in a minute in one of our demos, but that piece of content is just a list of resources that are used by the app. And so it starts with cache manifest, all in caps, and then each line after that is just a list of the resources that are needed by that application. And another nice benefit of using app cache, and actually the primary reason app cache was added was for offline capability in the web, but it does have that nice added benefit that even when you're online, the content starts to render and display immediately. And that's actually the reason that we like the application cache. It actually has a substantial performance benefit in mobile.
The next rule we propose to defer parsing with JavaScript. As I just talked about the low CPU power, low memory. So enables the parsing of the JavaScript will put the upfront time for your page to be loaded. If your JavaScript don't need to be executed right upfront, you can defer parsing them or even defer load them. Here in this table, I did some experiment to run 4 popular JavaScript libraries and measured how long it takes for iPhone 4 to parse them. We get the result, it's almost 1 millisecond per kilobyte. So if we can defer parsing of them, your page will be showed up quickly. And there are several ways that you can defer parsing of them. One is if you can defer load them, then do defer loading the JavaScript. That's the best way. If you can't, you can put your JavaScript in a literal string or in the comments. In that case, the JavaScript engine will parse them very quickly. That's also inside Google, the Maps team or the Gmail team using those techniques.
And there's actually a nice blog post a couple years ago the mobile Gmail team wrote that goes into some more detail about how they accomplished this, that you can take a look at on the web if you search for mobile Gmail performance, I believe, blog. Using your favorite search engine, you should find that blog post, and they'll go into more detail.
The other rule we propose to make your landing page redirects cacheable. We know that each redirect there involves at least a reconnection and a request. That's 2 round-trip times. If the host is not resolved, you have another DNS lookup. So there's multiple round-trip times involved in each redirect. For example, if example.com redirects to www.example.com, which redirects to m.example.com, and then redirect to the final landing page, www.example.com/m. There are 3 redirections. We have seen this pattern in the real world. It may not be the real example.com. So to solve this problem, if you make your each of those redirections cacheable, so that when the browser looks up the first URL, it will just use the cache and use your final landing page directly. This won't save much for the first visit, but for the repeated visits, you will see the improvements. Yeah. The fourth rule we propose is to prefer touch events. As I have said before, this is a very unique rule for mobile only. The other rules we have proposed, they also work on desktop, laptops, but those are more important on mobile because of the network, the CPU. But this interaction mode rule is quite unique here because the phone has this on-click event. If your event handler listens to on-click handler, you won't get the event until the browser waits 300 to 500 milliseconds. Here I can show a short video that demos the click. You can also go to the URL I put there, look at the, show the demo yourself.
So if you have a mobile device, you can actually try this out. It really shows the difference in sort of response
that won't
time.
work on the desktop since the desktop has no on-touch event.
We'll show the video, but it's most compelling if you just try it yourself. You'll really see the difference in response time.
Yeah, on this screen, we have two buttons. One is slow button, the other is fast button. On the right is a slow button. If you click, you can see there's some change on the text area, but it won't just show the change right away. But on the left, you can see it's more responsive. And also on the slow button, if you click too quickly, the browser don't know what you are doing, so it just wait until you end, so it will think, oh, finish this click. Yeah. The last rule we propose to enable keep alive for your server. Each connection need sorry. There are many resources in each of the web pages, but each resources need a request. For each request, you have to connect the server and send the request and then receive the response. If the connection can be reused, you will save the time to reconnect the server. Here in this chart, I show a connection view. That's each row in this chart is a connection. There are one request on each of the row. The brown bar shows the connection time. Green shows sending request and waiting the response. And the blue bar shows the receiving time. We can see that every request, there is a connection cost upfront. If you have enabled your server to use Keep Alive, I will show the next chart. It's the same 16 resources and the same 6 connections. We have done this test using webpagetest.org, which uses IE8. It has a maximum of 8 connections per host. So all those resources are on the same host. Here on the right chart, when the server has enabled Keep Alive, we can see on each row, on the first row, there are 4 resources, but only 1 connection cost. The second row, we have only 2 resources because one of the resources took longer. But overall, we saved the connection cost.
And so we'll finish by doing a survey of tools available to analyze mobile web performance. So before we do that, or as a first tool that we'll talk about, we'll have Amir Rosenberg from Compuware come up and talk about their use of page speed in the Gomez recorder and in Gomez mobile products. So welcome, Amir Rosenberg.
Thanks, Bryan and Libo. This was great. Hi, everyone. My name is Amir from Compuware Gomez APM. I'll do the mandatory one slide about who we are and what we do. And so we are in the application performance management business. If you have a website, a mobile website, a native application, or an SMS application, and you really care about it, whether it makes money for you or it's a brand play or whatever it is, we're in the business of telling you whether the application is up, is it performing in the eyes of your end user, wherever they may be. And if it doesn't perform for whatever reason, our job is to quickly tell you or give you enough information to go and fix the issue that causes the performance to be degraded in the view of the end user. And so that's who we are. And I am the mobile product manager in the Compuware Gomez APM. And what I wanted to do today is just to give you a couple of things that we're seeing in the marketplace and what we're doing with mobile page speed. And so, you know, mobile is a terrific opportunity. You have an opportunity to get closer to your end users and learn more about them and give them really unique experiences. But what we're seeing is that mobile users really don't have a lot of patience with applications that don't really perform well or have all kinds of latency issues. And so a lot of users, and you know, check it out with yourselves, you know, expect mobile experiences to perform even better than desktop experiences. And you can think about navigation applications or healthcare applications if a physician gives a prescription over the weekend and so forth. They need access to information rather quickly. And they need the experience to perform really well. And so what we're seeing is that, like I said, a lot of people expect the experience to perform as well, if not better. And a lot of people are actually unhappy with the experiences. And when they are, they're unlikely to come back to it. In fact, nowadays, when you know it's not so much anymore about the carrier and so forth, many of them actually will move to your competition, right? So there are many applications out there that just choose another alternative. And so one thing that we've done here is we actually measured the abandonment rate by page load time. And the really interesting thing that correlates well with what Bryan mentioned earlier is those 2 seconds as the page loads for the first time. And so what we're seeing is that in mobile, users are actually a little bit more tolerant of the experience and wouldn't abandon it right there and then. And what we're hoping to see is that indeed the 4G deployment of networks would actually reduce that and would give us some more breathing room. However, what you can see out there is that users on mobile will abandon the pages or mobile native applications pretty quickly after that, almost as fast as desktop web. And we see that that trend will actually increase over time. I'm sorry. And so one of the things that we've done with Google, we are also very much aligned with making the web faster and making it much better. This is probably the key tool that our users would be using to describe web, mobile web, and native application experiences. We call that the Gomez Recorder. And we've actually integrated the page speed recommendations to every one of our users. And so if you use this tool, you'd effectively go to your website and click through and go through the various steps that you want to then monitor. And then you run the scripts again. And for each of the pages that you go through, you will actually get the recommendation of the page speed as you've seen earlier with the standalone page speed description that Bryan gave. And so this is really a tremendous help to our customer base because now not only they can you know, become aware of performance issues post-production in the field, but actually they can get recommendations to what to fix on the website pre-production as they, you know, as they create the experience. So thanks for Bryan and the team to give us those APIs and let us use them. And that's kind of my piece.
Great. Thanks. Thanks, Amir. Okay, so now Libo and I will do a brief survey of other mobile performance tools. So 2 that we've built in the PageSpeed team, and 2 that were built that are third-party tools that were built outside of our team.
The first one we will show PCAP perf that will help you analyze your mobile device, mobile analysis that will show the waterfall chart to see which request at what time, and then you can see the bottleneck of your web page.
Second, we'll talk about PageSpeed Online, which performs PageSpeed analysis on websites. It also has the ability to load the mobile-specific version of a page and perform mobile PageSpeed-specific analysis on that site. So we'll look at a demo of that shortly. And so another tool that we'll look at is a tool called JDrop that was built by Steve Souders, and I'll talk about that in a future slide.
Last, we will talk about Blaze.io that provides a service to analyze your mobile set. Also, I can show waterfall chart, and they have provided video capture. First, let me show the PCAP perf. Last summer, when we started to looking at how to optimize mobile web pages, we found that there are basically no tools for us to use at that time. So we looked around and found that there are some hard tools that can show the waterfall chart from the hard format. And then there's also an open source project that can convert the PCAP file to hard, which PCAP is a TCP dump or Wireshark capture of the packets. So with those available tools, then we come up with this setup to capture the mobile traffics and then convert them to hard and then show in a waterfall chart. So the setup is we run TCP dump and Wireshark on a laptop computer. And the laptop computer has two network ports. One is wireless that can connect to a phone. The computer is set up as an access point. So the phone connects to the computer. And the computer uses another network connection to the internet. So all the traffic is on your phone goes to your computer and then to the internet. You run TCP dump or Wireshark on your computer, you capture the traffic and save them to a PCAP file. And you upload your PCAP file to pcapperf.appspot.com. Magically, you will get this waterfall chart. Now let me show you a demo. This PCAP perf. First, I have uploaded some examples on the site. You can just click view waterfall chart. You can see one of those examples. Now let me upload one of the captures Bryan just did this morning or last night. Yeah.
So it's so this was captured using TCP dump just as Libo described. And so that's the first step. So before we do this, actually, if you go to the site and click on how to capture mobile traffic, it'll go over the specifics of how to use TCP dump to get the right data. And then.
And we have a checkbox to remove all your cookies so that if other people happen to have the URL you have uploaded, they won't see your privacy cookies. If you want to keep them, you can uncheck that box. So this shows the Google's mobile site. At the top, we can see there is a M ? manifest. That's the application cache. And the second, it will request the www.google.com page.
So here's actually the HTML, and we can look at that and see indeed. Oh, well,
the response is, I think.
Oh, response. Thank you.
Yeah.
Indeed, HTML, and here we go. Manifest equals, and so this is using that. Use an application cache. It's something that Google.com uses, as an optimization for mobile. And then subsequently, these are actually out of order in the display due to the way the network stack is configured. Then you can see that here's the actual manifest response. And so it starts with cache manifest and then lists all those resources that Google.com needs to actually render its page as an application either offline or instantly as soon as the user types in Google.com.
And also PCAP perf integrated with page speed. So if you run this hard to page speed, it will analyze this web page to show what page speed rules applies on this page. I think that's all for PCAP perf.
Okay, so that's PCAP perf. So why don't we look now? There are slides. take a look at PageSpeed Online. So I'll go ahead and do a demo of that site. So pagespeed.googlelabs.com. And here we go. I'll actually switch back to desktop. And so we can enter a web page. Oh.
Someone pick one?
We'll do CNN. Any site will do. But so we'll run. So this is running this sort of traditional desktop analysis, the PageSpeed desktop analysis for their desktop site. And so what we get back here first at the top, the page, this page, CNN, got an overall PageSpeed score of 67 out of 100. So that indicates that there's some room for improvement for CNN to become faster, somewhere in the middle essentially, right? And then over here on the left, we get the same prioritized suggestions that we saw in the screenshot of the browser extension. And so the top thing that this site can do is to turn on browser caching. And so if we click that, we get some information about what that means. And then if we're curious, okay, how do I do that? Or specifically, yes. Specifically, what does that mean? You can click through and go to our documentation and learn all about that. And we'll go into detail about the right headers you have to set and what optimal settings are for those headers and all that good detail. So, sorry. Let's find the actual aha. And then so there are the specific suggestions associated with each rule. So in this case, we see there are a number of resources that don't have expiries and thus could benefit from caching headers, which would allow them to be read from the browser cache as opposed to fetched from the network when the user returns to the page. And so subsequently, we see each suggestion, listed in order of priority. But if we want to get a mobile-specific report for the site, we can just simply click Mobile Report. And then what we get back is a very similar looking page, but the differences here are that the mobile-specific version of the site has been loaded. And so the first thing we see actually is that the site www.cnn.com redirected to m.cnn.com, the mobile-specific version of the content. And so we get a PageSpeed score here, 61, a little bit a different score, but in the same ballpark. And we see suggestions over here on the left. And in fact, leverage browser caching comes up as the same highest priority suggestion. But if we click through, what we see is that the specific resources being analyzed and suggested for caching are entirely different from the desktop version. And so using this tool makes it really easy for you, if you have a mobile-specific version of your site, it makes it really easy for you to analyze the mobile-specific version, whereas it can typically be harder to do that using a desktop browser if you're using the Firefox add-on or the PageSpeed add-on for Google Chrome. So in addition, we've got some other rules in the PageSpeed Online offering for mobile analysis. In our experimental section right now, we have a suggestion to use an application cache. And right now, it's simply says, essentially, use an application cache, and if you do that, the page will be faster. Going forward in the coming weeks, what we'll do is we'll actually provide what we believe is an optimal application cache for that page for you, so you can just take that content and use it. Of course, we'll be clear here, and I'll say now, it's always important to look at the suggested content and make sure it really does make sense. We'll do our best, but you know your site better than we do, so we'll give you as much information as we can, and then you can go from there. So that's PageSpeed Online. So the third tool is a tool called JDrop, jdrop.org. It's built by Steve Souders and launched recently in the last few months. And the idea here is that there's all sorts of analysis you'd like to do on your mobile device, be it looking at the DOM on the page or the content of the HTML document, looking at local storage or their HTML5 properties. But analyzing that content on this tiny screen is really not a pleasant experience, right? You've got this tiny screen. You'd much rather look at that content on your desktop or laptop big screen, And so the idea with JDrop is that you log into JDrop here and on your laptop or desktop. You perform analysis using bookmarklets on the mobile device, and then post the results of that content to JDrop where it's stored, and then because you're authenticated on your desktop, you can see those results on the big screen. And so the nice thing about JDrop 2 is that it's totally plugin based and totally extensible. So they've got lots of really great bookmarklets that you can use today. But if there's something that's missing that you'd like to add, it's very easy to add a new bookmarklet that does new kinds of analysis. So that's JDrop.
Last tool we want to talk about is Blaze.io, which provides a service you don't have to use your own mobile devices. They provide 3 devices now. You can choose one of them to run the URL you want, and then it will tell you overview of your how long it took to load the page, and what's the size of a page, the total number of bytes. And also, it can give you a screenshot of the site. And also, they have this waterfall chart. You can analyze the request, the bottleneck of the request. Lastly, it has a video capture. You can just see how your page is loaded on the phone. If you don't have so many phones, if you develop a web page, you can just run those phones without buying them myself.
So that's our talk. To summarize, we'd like to emphasize 2 points. The first is that the unique characteristics of mobile networks and mobile devices present new optimization opportunities. So things like the mobile channel establishment time, like we talked about, and limited CPU and memory of the devices mean that there are new, both new optimizations that we need to perform to make our mobile websites fast, and also sort of reprioritization of existing optimizations based on these new characteristics. And so second, you can use PageSpeed and these other tools we've talked about to understand your performance and to optimize your site for mobile performance. Any questions? And if you do have questions, please step up to the mic. Thank you.
Hello. I was wondering, is there a way to tweak the user agent that you use so that if we want to test the tablet version versus the mobile version?
From the desktop browser? Yeah, so you can actually, so in Chrome, so that PCAP file, actually, I cheated a little bit, and I told Chrome to use a mobile device user agent when I did that. So you can actually, in the Chrome case, you can do --user-agent on the command line and then specify a UA, whatever you want. And the nice thing about using a browser like Chrome or Safari is that many of the browsers on mobile devices are WebKit-based, as are Chrome and Safari. And so you can expect content that's targeting mobile devices to render correctly in those browsers.
So, but what about from your website, when you can run view mobile report?
Oh, the one, the PageSpeed Online?
Yeah.
Yeah, it actually does the same thing. So it uses a WebKit-based renderer, and it uses a different user agent to essentially tell the server, to look like a mobile device or a desktop device.
But can you tweak that one?
Oh, can you override that as a user? We don't provide that capability today, but it's something we could do.
Right, thanks.
So we'll think about that. Thanks.
I had a question about the manifest file that you showed for google.com/m. Towards the bottom, you actually had, there weren't any resources, there were just domain names.
Oh, let me. They were just, I'm sorry?
They were just domain names. There weren't any resources actually at the domains, and it looked like there were subdomains of maybe image hosting, static domains that you were using.
Yeah, let me go ahead and look at that. So I actually don't work on search, on mobile search, so we may not be able to answer, but we can look at it and see.
I guess I was curious, yeah, some of there. So is that, you're not actually looking for a resource. Why are you doing that? Is that because you're kind of caching the IP address so that you don't have to go back and do another DNS query, or what's the purpose of that?
Which one?
Further down, ytimage.com, you've got I1, I2, I3, I4, but there are no resources thereafter. Usually, in the example you gave, it was my.css and my.js.
Sure. Yeah, that's interesting, actually. So I actually don't have a good answer. That's a really good question. I think you're probably right. It's probably a pre-resolve, or it's whitelisting in those domains. I actually don't know. I'm sorry to say. I wish I had an answer. One of the things that we found in our research with manifest support is that because it's relatively new, different browsers have different spec compliant or quirks. And so in fact, there's this nice feature of manifests that is you can have a network section where you can whitelist. You can basically say, here are the things I think I need. And then you can say network : star, and that essentially means anything I didn't declare here, go get it from the network. And we're like, well, fantastic. That means that, if you forget it, at least you can fetch it from the network if you're online. Turns out,
some browsers does not support this feature.
Yeah, it may very well be that these lines are working around sort of quirks in current browser implementations, or it may have something to do with the spec, but it's not immediately obvious to me what's going on there. So it's a good question. If you sync with me afterwards, I can take your email and try to find out.
Okay, and then I had another question. You didn't talk about WebSockets at all. And I think I read somewhere that if you use Chrome and you use google.com, it uses WebSockets more than HTTP. I don't know if that's accurate or not.
It may be that, so it uses the Speedy protocol. I don't know that they're making extensive use of WebSockets today. I think certainly WebSockets is the kind of thing that we'll start to suggest as it becomes sort of more proven and more well used. At this point, we've seen some issues with WebSockets around, essentially proxies sometimes can get in the way. HTTP proxies or ports can be blocked if you're doing it on a non-standard port. And so we're sort of waiting to see how that plays out over the coming months, and then, or 6 months, say. And if things look good at that point, we would certainly recommend using WebSockets because they have some nice characteristics.
Thank you.
For performance. Yep.
Hi. So have you seen the strictness of the page having a page load time impact? So if you have a page with a lot of tag soup in it, like it's not well-formed DOM, does that make a big impact? I didn't see it as one of the line items up there in the recommendations.
Yeah, today we don't suggest well-formed HTML. We haven't seen any compelling evidence that suggests that it will load more quickly. If we saw information that did suggest that, so let me just bring up the response. We would certainly, that actually looks very well-formed. Traditionally, major sites actually have not served well-formed content.
Right.
And so in our test, as I said, we haven't seen any difference when we do A/B tests. And it also seems that other sites either haven't investigated themselves, or if they have, they haven't seen any difference either. But I will say, if somebody shows that there's a substantial difference, for some aspect of well-formed HTML, we would absolutely add that to the page speed rule set. We just haven't seen evidence of that yet.
Because I've heard anecdotally that the tag soup, causes the, like Firefox to go into a failure case, and sometimes if it's, it'll have to go into a backup or lookup or something like that. But I haven't heard any proof one way or the other that it actually makes a difference. So, okay.
We'd be glad to. So we have a mailing list, page-b-discuss on Google Groups. If there's a link or something like that that you could point us to, we'd love to know about that, and we'd certainly add suggestions for that.
Great, thank you.
If that proved out. Yep. Thanks.
Maybe an obvious question, but I have to ask it. Would you recommend against using GWT for a mobile web app? If so, why in particular? And if not, can you say anything about optimizing such a website with page speed?
Sure. So the first thing I'll say actually is that there's a talk tomorrow about using GWT to build high-performance mobile apps, and so I would that talk will, I think, give you a better idea for performance, and I certainly know too that the GWT team from the beginning has been very mindful about about performance, and they actually try to roll in a lot of these techniques into their compiler so that you don't have to think about them when you're building your app, but you automatically get things that we suggest, like deferring unused JavaScript, minification of content, spriting, and things like that. So while I don't know specifically in the mobile space of any issues, positive or negative with GWT, my expectation is that they're probably very high performance today, and the nice thing about using GWT is that as they constantly improve it, and so you'll benefit from those improvements automatically.
So would you say there's less need for an analysis tool like that?
That's an interesting question. So I certainly would always run, so I'll give actually an example. So pagespeed.googlelabs.com uses GWT actually. And one of the things we did initially was we there's some browser feature detection that GWT likes to do, and that by default runs client side. And so we ran some page speed analysis, and we saw, oh, okay, that's actually adding some serialization, some performance impact. And so we either had just rolled out or are about to roll out an optimization where we do that detection server side. And so so that's something you can do with GWT. It just may not be turned on by default. And again, I'm not a GWT expert, so I would recommend asking the guy speaking tomorrow. But I think it makes sense to use both tools. GWT will do a lot for you, but it's always good to sort of double check and make sure with a tool like PageSpeed.
Thank you.
Brian, can I jump in? This is David Chandler. I am on the GWT team, and that's a great answer that you gave. I'm the one giving the talk tomorrow.
Awesome.
And Yes, it's still worthwhile to use the tools because there are features in GWT that can be used to improve performance. One of them, for example, that we're working on for the next few months is an app cache linker that will automatically generate that manifest for you. But you'll still want to run page speed first to determine that you could benefit from that kind of a thing. So, thanks.
Great.
Hi, two questions. First, what in the manifest, what is your guys' strategy for, like, in the case, the example you gave, like you're caching out some JS files, what if you need to pop that JS file? Do you just rename it something else? Or like, how's the manifest structure normally work in terms of telling it, no, there's a new version that you should be using?
In terms of changing the content?
Yeah.
Do you want to talk about how that's done?
The application cache is a relatively complex thing. If you have the application cache already on the browser side and you are changing the resources on the server side, the browser may not notice that until you change your manifest itself. Then the browser will start reloading all the resources again, or at least to check if it's changed. One technique is to change the name of your resources, and this can be done using mode page speed. It will can automatically, if you change your content, it will automatically change the name of your resource. It will solve this problem. And then you have to regenerate the manifest. That's another problem that needs to be solved.
Interesting. And then I was kind of surprised at how high some of those numbers were in Froyo for the JavaScript rendering. In cases like that, it almost seems like you could make a good argument for, depending on the functionality of the page, to just do it all server side. Is that a fair assessment?
I think that's a very a reasonable way to address. So one of our suggestions is to defer parsing of JavaScript, and one of the ways to accomplish that is to do as much as possible pre-rendered on the server because you'll have more CPU there. So the user, if you do that, I suppose you want to be mindful that so another technique that is wise to use is called chunked encoding. And the idea is that you push data down as it's generated on the server. So if what you're doing is really CPU intensive, you don't want to block sending the first byte back to the user on all that work. And so using chunking in combination with server-side rendering, I think would be a great way to speed up mobile performance.
Perfect, thanks.
Mm-hmm.
Hey. Can you talk a little bit more about HTML5 application cache and like what types of things you're caching and whether that's like for like targeted at specific devices or just like in general, or just want to know more about that?
Sure. Do you want to start with that?
Yeah, the HTML5 application cache, I think it's relatively new. The older browsers support, most of the WebKit browsers support HTML application cache, but there was a bug we just found out that if you use the network : that basically means everything else not listed in the application cache, go to a network, download them. But the older implementation of WebKit does not implement this rule, specific rule. So if you left them out, those will stuck on the browser cache. So you will never get updated. That's I found out hardly.
In terms of browser support, I think all the sort of most, I actually don't know about IE9. Does anyone here know if IE9 supports app cache? I can say, so the nice thing about app cache in mobile is that the predominant devices in mobile use WebKit, and WebKit has very good support. And so, iPhone and Android both have really great app cache support. And so while on desktop, it actually has benefit on desktop as well. The page will load instantly on desktop, and it makes sense to use it. But you won't reach all your desktop users because not all of them have support. But the support is, virtually everywhere for mobile users.
Cool.
And it's improving, too. So I would definitely recommend, based on what Libo said, definitely test on a variety of devices, whatever you have available, just to make sure, because it is changing rapidly, too. So if you can test a generation or two back, it'll help you to find bugs as you roll that out.
Cool, thank you.
Okay, 38 seconds left. Anyone? One more? Thank you.
Thank you.